In this video, we are going to talk about dividing radicals as well as something called rationalizing the denominator. So first, when we have radicals in a fraction or with division, there's a rule we want to make sure we remember. So when we have like the square root of a over the square root of b, we can write that as a big root or two little roots. We can kind of convert them back and forth. So let's put this into action. So in number 1, I have a big square root over 3 over 16. Well, I know 16 is a perfect square. So I can actually take this big root and split it into two little roots. Now, the square root of 16, this is a perfect square. So instead of square root of 16 on the bottom, I can make it a 4. And on the top, I'll have square root of 3. Now, when we're dividing radicals and rationalizing the denominator, our goal is to always make sure there's no radicals or roots in the denominator. So that's why this rule of splitting is really helpful, because now I no longer have a root in the denominator. We can also go the other way. If we have two little roots, we can always simplify this and write it as a fraction over a big root. This is helpful in situations like this because I can divide 18 and 2 and get 9, and I can divide x to the fifth and x to the third and get x to the second. Now, 9 is a perfect square because the square root of 9 is 3. X squared is a perfect square. The square root of x is x. Technically, we could have also wrote this as square root of 9 times square root of x squared, because those are also equivalent. And that could have also helped us get here, but we don't necessarily need that intermediate step. The next section of our notes is going to talk about what do we do if we have a root in the denominator. So, for a radical expression to be considered simplified, there has to be no perfect squares under the radical, no radicals in the denominator, and no denominator under radicals. So what does this mean? That means we cannot have any sort of root in the denominator of our fraction. So in order to make it so there's no root in the denominator of a fraction, we do something called rationalizing the denominator. So how do we do that? Well, we're always going to multiply by something that'd be equivalent to 1, aka we have to multiply the same thing to the top and the bottom. And our goal is to create a perfect square in the denominator. So let's put this into action in number 3. So in number 3, zoom in a little bit, we have 4 over square root of 2. Now, I want to multiply this bottom by the square root of something that's going to give me a perfect square in the denominator. So what are my perfect squares? So let's review that. So some of my perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, so on and so forth. So our goal is to get one of those numbers underneath the radical, and usually the smallest one possible. So in this case, if I multiply by square root of 2, that'll get me a square root of 4 in the denominator, which is good. So, but whatever I do to the bottom, I have to do to the top. Now remember our rules with multiplying. I'm not going to multiply 4 times 2, because 4 is an outside number and 2 is under the radical. So I'm just going to write it as 4 square root 2. Now this will continue to simplify. Square root of 4 is 2, and I'll still have 4 square root 2 on top. Now these two outside numbers, this 4 and this 2, will simplify. 4 divided by 2 is 2, so my final answer will be 2 square root 2. Let's try the same idea with number 4. So in the bottom, I want to multiply by something that's going to give me a perfect square. So let me scroll back and kind of look at those perfect squares. 1, 4, 9, 16, 25, 36, 49, 64. So 6 times 6 will give me 36. And typically this will be our go-to, is to multiply by the same number. And so that'll give me a square root of 36 in the bottom. Awesome. But whatever I do to the bottom, I have to do to the top. Again, this 6 is an outside number, this 6 is an inside number. So I'm not going to multiply them, I'm going to write it as 6 square root 6. Now the square root of 36 is 6, so I'll have 6 root 6 over 6. Similar to the last one, I can simplify this 6 with this 6, which will divide to 1. So my final answer will just be either 1 square root 6 or just square root 6. All right, let's try number 5. Now 5 is going to be similar, but we have a little bit more complicated numerator. So square root of 2 times square root of 2 will give me square root of 4. But whatever I multiply the bottom by, I'm going to multiply the top by. Now, what can I multiply on the top? I cannot multiply root 2 by 3, but I can multiply root 2 by root 5, so I'll have 3 square root 10. Now, this will simplify to 3 square root 10 over 2, because the square root of 4 is 2. And since the 3 and the 2 don't simplify in this case, this will be my final answer. Let's do a couple more of these. Let's move to number 6. So again, I have a 6 in the denominator, so I'm going to multiply by square root of 6, because that'll get me square root of 36. But whatever I do to the bottom, I have to do to the top. Now, square root of x and square root of 6 are both in radicals, so I'm just going to combine them to get 6x underneath the square root. Now, 6x underneath the root over a plain 6, because the square root of 36 is 6. Now, the 6 on top is an inside number, and the 6 on the bottom is an outside number, so I cannot simplify this anymore, so it's going to stay like this. In number 7, before I multiply, I'm going to use my rule that I can split this into 2 roots, because I think that'll make this problem a little bit easier. So first I'm going to split it as square root of 9x over square root of 2. Remember, if we have a big root, we can always split it into 2 little roots. Now I need to get rid of the root in the denominator, so since I have root 2, I'm going to multiply it by another root 2, because that'll get me root 4 in the denominator, and I'll have 18x in the numerator. Now, I know my denominator will become a 2 because the square root of 4 is 2. But actually my square root of 18 will simplify. So make sure we're checking that, especially once we get a little bit bigger numbers. Square root of 18 breaks down into 9 and 2 and 3 and 3. So the square root of 18x is going to be equivalent to 3 square root of 2x. Because remember, the pair comes out, the leftovers stay in. So I'm going to have 3 square root of 2x on top. Now, since my 3 on the outside and my 2 on the denominator do not simplify, this would be my final answer. Let's look at our last one on this page, number 18. Now I'm going to use my rule of taking my 2 little roots and making it a big root, because I think that'll help me simplify this a little bit. So I'm going to make it a 1 big root, and then I can divide. So 18 divided by 2 is 9. I'm actually still going to have a fraction, so I wrote that 9 a little big. So 9 on top, x squared also have on top. Now with my y's, I have 1 y on top and 3 y's on the bottom, so I'm going to be left with 2 y's in the bottom. Now, I could simplify this the way it is, but sometimes I think it helps to just split it back into 2 little roots. Now, the square root of 9 is 3, and the square root of x squared is x. The square root of y squared is y. So this would simplify to this. Now technically we could have gone from this step to this step. Just make sure that you simplify by taking the square root of the top and the bottom. Sometimes we forget that with the big square roots. The last type of simplifying we will do is when we have not just one radical in the denominator, but we have like a binomial in the denominator. So let's take a look at this one example. So we have 5 over 2 plus square root 3. Now, our denominator in this case is 2 plus square root 3. So we are going to multiply something called the conjugate. This is a really important vocab word, so make sure that we make note of this, because you're going to use it basically for the rest of your math career. And the conjugate is always the same binomial, but what we're going to do is instead of having 2 plus square root 3, it's going to become 2 minus square root 3. So the 2 and the root 3 stayed the same. All we did was change the sign that was between them. And this is what will always happen with the conjugate. So what I do is I'm going to multiply this by 2 minus square root 3, or the conjugate. Now, just like we talked about on the front page of the notes, you always have to multiply the top and the bottom by the same thing. So now we're going to have to use our multiplying rules. So let's distribute on the top first. So I'm going to do 5 times 2 is 10. 5 times negative square root 3 is negative 5 square root 3. Now let's distribute on the bottom. 2 times 2 is 4. 2 times negative square root 3 is negative 2 square root 3. I'm going to have to make this bottom a little longer. Then I have to do root 3 times 2, so that's positive 2 square root 3. And then square root 3 times negative square root 3 is going to be negative square root 9. So let's simplify this. Well, the top is not going to simplify. So let's leave that. In the bottom, my negative 2 root 3 and my positive 2 root 3 are going to subtract. So they're going to go away. So this should always happen when you do the conjugate. That's why we multiply by the same binomial but with the opposite sign, because that means our middle terms will always subtract. Now, I have negative square root 9. Well, what's the square root of 9? Square root of 9 is 3, right? Because 9 breaks down into 3 and 3. So in the bottom, I'm really going to have 4 minus 3, because that negative square root of 9 becomes a minus 3. So I'll have 10 minus 5 root 3 over 1, which is really just 10 minus 5 root 3 as my final answer. If you leave it over 1, that's okay, but technically the most simplified form, we don't need the 1. So let's try a few more of these. If I look at number 9, I notice I have 5 minus square root of 2 in the denominator. So I'm going to multiply by 5 plus square root of 2. And whatever I do to the bottom, I have to do to the top. And again, remember, it's always the opposite sign. So in this case, I had a minus in the original problem, so I had to multiply by a plus. So in the top, I'm going to distribute. 3 times 5 is 15. 3 times root 2 is 3 square root 2. Now in the bottom, 5 times 5 is 25. 5 times root 2 is 5 square root 2. Negative root 2 times 5 is negative 5 square root 2. And negative root 2 times positive root 2 is negative square root 4. So in the top, I'll get 15 plus 3 square root 2. That's not going to change. In the bottom, my 5 root 2 and my negative 5 root 2 will subtract. And again, this should always happen. So as you get stronger with your conjugate, you don't necessarily have to write out all the steps. And I'm okay with that. In the bottom, though, I'm going to have 25 minus square root of 4. Well, square root of 4 is 2. So I really have 25 minus 2. So my final answer will be 15, 3 square root 2 all over 23. Now 15, 3, and 23 don't have anything in common. So this will be my final answer. All right, pause the video now and try example 10. When you're ready, play the video and see if you got the right answer. All right, so in this example, I have 10 plus square root of 2 in the denominator, so I'm going to multiply by 10 minus square root of 2. So that means in the top, I'll get 60 minus 6 root 2. In the bottom, I'm going to get 100 minus 10 root 2 plus 10 root 2 minus square root of 4. So I'll have 60 minus 6 square root 2 all over 100 minus 2. Because again, these middle guys subtract. 100 minus square root of 4, well, square root of 4 is 2. So I'm 60 minus 6 square root 2 all over 98. Now this can actually simplify one more time. And that's because my 60 and my 6 and my 98 are all divisible by 2. So if I divide each of those numbers by 2 to simplify this fraction, I'm going to end up with 30 minus 3 root 2 all over 49 is my final answer. All right, now that we did 10, pause the video and try 11. When you're ready, play the video and see if you got it correct. For question 11, my denominator is 5 minus square root 7. So I'm going to multiply by 5 plus square root 7, because again, it's always the opposite sign in the middle. So on top, I'll have 45 plus 9 square root 7. In the bottom, I'll have 25 plus 5 square root 7 minus 5 square root 7 minus square root of 49. On top, I'll have 45 plus 9 square root 7. In the bottom, again, my middle subtract. So I'll have 25 minus square root of 49 is 7. So 45 plus 9 square root 7 all over 18. Now, kind of like with the last problem, my 45, my 9, and my 18 all can be divided by a common factor. And in this case, they're all divisible by 9. So if I divide them all by 9, I'll be left with 5 plus, you could write 1 square root 7 or just square root 7. All over 18 divided by 9 is 2. All All right, our last one. Go ahead and pause the video and try 12. When you're ready, play the video and see if you got it right. For number 12, I'm going to multiply by square root of 3 plus 1. Because again, it's always the same denominator, just change whatever the sign in the middle. In the middle was a minus, so I'm going to multiply by a plus. Whatever I do to the bottom, I have to do to the top. So square root of 3 times square root of 3 is square root of 9. Square root of 3 times 1 is just square root of 3. In the bottom, square root of 3 times square root of 3 is square root of 9. Square root of 3 times 1 is square root of 3. Negative 1 times square root of 3 is negative square root of 3. And negative 1 times 1 is negative 1. So on the top, I can do a couple of things. Well, this square root of 9 is 3. So I'm going to have 3 plus square root of 3 in the top. Similarly, in the bottom, this square root of 9 is also 3. So I'm going to have 3 minus 1 because my middle terms are going to subtract. So my final answer will be 3 plus square root of 3 all over 2.